Greetings, CS240, Cyber 240 assembler students. Long overdue. Here is a video, several videos explaining how to do Lab 5. Lab 5 is not hard, but it has interesting practice and principles. And in this first video, we're going to see kind of the structure of the program. In the next two videos, we'll see how to do some of the guts of it. So the basic idea is, I gave you a skeleton program to work with, and you need to write 3 subroutines inside of that. That's your job, is to write 3 subroutines. And the main program looks kind of like this. And what it's going to do, this is the first part of the main program, what it's going to do is, using SASM, I put up a SASM version of the skeleton, finally. Using SASM, you'll put in the input window, which is over on the right, and it's probably going to be over on the left in the version that you see. You'll put some numbers. So you'll put 165 as an example, and then enter. Then you could put more numbers, and then the last number you'll use is 1, 2, 3, 4, 5. And this program's going to run. It's going to read these numbers one at a time and print stuff. So that's what it's going to do. What it's going to print is the number is, and then it'll print it in binary. And then after the binary version, this is 32-bit number, so that's 165 in binary. And then the last thing it will print is the same number in hex, which will be 000000 alpha 5. So I don't know if that came out on the screen. I'll put it over here. Okay. So this part on the right is kind of narrow. It ends up wrapping around in real life. You can expand in SASM. You can expand this out. So the number is, you typed 165, and the number is this. Okay. And then it will negate the number, print the number again, so you see what the negative looks like. And a third subroutine that you will call will print whether or not it's positive or negative. So here's your main program. And what you need to notice is what? So bin buff over here is going to be 32 bytes. And I could have said a res B of 32 or something, but I deliberately picked another syntax, but it'll be in your skeleton. It'll be 32 zeros. So that's 32 bytes. And this is going to contain this output over here, 32 bytes. So if you're printing it, it's what? It's ASCII characters, each of which is 1 byte. So that number which got typed in, you're going to have to format like a string in a high-level language. You're going to have to format a 32-byte string, and you'll put it into memory over here. And each bit of the original 32-bit number is going to be represented by a printable character. So we're printing it using our normal numerals, but okay, and there will be 0 numerals or 1 numerals and ASCII characters. I mean, just get that into your head. It's not that hard. So the main loop is pretty easy. GetDec is read a decimal number. It'll read a decimal number into EAX. It'll compare EAX with 1, 2, 3, 4, 5. If it's equal, remember how we did our if statements. We go to bye-bye. So the first time through, here's the top of the loop. The first time through the loop, we're getting 165. The next time through the loop here, we'll get 1, 2, 3, 4, 5, and we'll go bye-bye. Fine, okay. Here, it's being saved in case you want to restore it later. And somewhere up near the top, in the data section, in the BSS section, there's actually N is D1. So this is N is reserve 1 double word. Okay? So over here, the square brackets mean put it into memory, touch memory. So EAX, the number you read, is now stuck into N. Then here comes the new stuff. We're going to call bin convert. We're calling a subroutine. Over here is bin convert, and in the middle of this is where you write your code. I've provided you with push A and pop A. What are push A and pop A? That's push all and pop all. All what? All registers. The idea is as follows, and here's how I just started describing it in class. You're going to go away for a while, and you have a house sitter. And the house sitter comes, and maybe a visitor who comes and checks in your house every now and then. So the visitor comes and checks your house every now and then while you're away, and that visitor takes stuff out of the refrigerator. Okay? All right. Before you come back, the visitor puts stuff back in the refrigerator, so when you come back, the refrigerator looks like it was supposed to be. Okay? That's what we're doing. So inside of bin convert, we're going to be using registers. We're going to be using and modifying EAX. We're going to be using and modifying EBX or something, ECX, ESI, all these registers. We're going to be using them. What happens when we use them? The previous values in those registers get clobbered. They get overwritten. So what we're going to do is we're going to take the values that were in those registers, put them into memory somewhere. That's the push A. It goes on a stack. And we're not going to represent that now. The next lab you'll see in much more detail about the stack. And then before we leave, we put back into the registers what they used to contain. So here, we save the contents of the refrigerator. That's not realistic, but we're going to save them. And then over here, we put all the refrigerator contents back. And in the meantime, we can do whatever we want with the refrigerator, which is to say the registers. So in a high-level language, this is different. I mean, if you have a variable I in your main program, and then you call a subroutine, and in the subroutine you have a variable called I, they're usually not the same variable. There's one variable I in the main program, variable I in the subroutine is local to that subroutine. But the registers are built into the computer. There is only one EAX. There is only one BAX. So if I'm going to use EAX in this subroutine, I'm going to clobber EAX, which is up here. So this is why I do the push A and the pop A. And this is the return, the subroutine return. Okay, so we're going to call bin convert. In bin convert, we're going to push A, we're going to do some stuff, we're going to pop and return. So bin convert's job is to get a bunch of ASCII characters into this 32-byte buffer, so that later on when we print string, we're going to print string this stuff, and we're going to print string bin buff. Bin buff better contain that. Then later we're going to print string hex buff. Hex buff is going to be 8 characters over here. Got it? So the job of bin convert is to take EAX and examine it a bit at a time and put characters into bin buff, boom, 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 so that when we print the string of 32 bytes of characters, we get some printable stuff over here. You'll notice we call bin convert, and then we call hex convert, and we don't do anything in the meantime. We never reload EAX. Okay? We assume that this subroutine does not destroy EAX for us. See? Call bin convert, call hex convert. There's an implicit assumption there that EAX has not changed. We're going to get a printable version of EAX. We're going to get another printable version of EAX. Okay? We're assuming the subroutines do this stuff. Okay? Happiness? All right. That's the end of this video. It's got the subroutine entry and exits, the general plan of the program, and what we're trying to do. In the next video, we'll take a look inside bin convert.